The second concept in terms of exponentials that we want to look at is the natural exponential function. And the natural exponential function is based off of the value e. E is a constant. Just like pi is 3.14159, e is approximately 2.71828 and comes from this fancy expression of 1 plus 1 over x raised to the x as x gets closer to infinity. You'll study that more in calculus, but really for now, just be familiar with the idea as e as being a constant, and we're going to be seeing it in our compounding continually interest formulas, as well as a couple of examples we'll see later in the chapter. So the first thing is evaluating an expression with e, and e is built into our calculator. On the TI-84, you hit the second button, and then hit the ln button, and you see the little e that's in blue above that, and I would type in my expression e raised to the 2.34, or 0.234 I should say, and that is going to give me 1.2636. And since we're looking at this from the AP perspective, we want to round everything to 3 decimal places. 1.264. The next thing we want to look at is the application of exponential functions, specifically compounding interest. And there's 2 formulas we're going to look at. A equals P times 1 plus R over N raised to the NT. The other is the compounding continuously formula. A equals PERT. P stands for the principal, which is your starting amount. R is the rate, which needs to be a decimal. So you'll need to convert your percentage to a decimal by moving your decimal point over 2 places. Time is going to be in years. And then N is the number of payments in a year. And if you want to have a quick review in terms of payments in a year, N is going to be equal to 12 if you're monthly. N equals 4 if you're quarterly. N equals 1 if you're yearly. So suppose you've got $4,000 interest and you're investing at 5.25% compounded monthly. How much are you going to have after 6 years? We want to look at this being compounded monthly and then comparing what happens if we compound continuously, meaning we've got interest occurring more than once. So A equals P 1 plus R over N raised to the NT is our interest rate formula when we are not compounding continuously. We know we've got $4,000. My rate is 5.25%, and we need to convert that into a decimal. You might say, hey, that's already a decimal, but there's also the percentage in there. So we need to move that decimal point over 2 places. And since we're compounding monthly, N is going to be equal to 12. And then T is in years, which is 6 years. I can plug that expression into my calculator, and I'm going to get $5,477.27. Be sure that you do your order of operations correctly, where first you do inside your parentheses, then you're going to raise that to the 72nd power, which is what 12 times 6 is, and that entire result you're going to multiply by 4,000. The second part of the problem then asks for us to solve compounding continuously, and that's where we use our PERT formula, where both R and T are in the exponents. Once again, 4,000 is the starting amount. Our rate is going to be a decimal, and we're doing this over 6 years. And if you plug that into your calculator, you should see you get $5,481.04. So slightly larger, even though this is being compounded continuously versus compounded monthly. The last problem then asks for us to find the starting amount. So we're given the final amount and we're working backwards. We want to find 9% interest, which we know then my rate is going to be 0.09, converting that to a decimal, compounded monthly means that n is going to be equal to 12. And I know this 30,000 is my final amount. And 15 is going to be the t. So I've got almost all my variables. I'm going to plug these into my equation. And I know not to use this one because I'm compounding monthly. It's not compounded continuously. So my amount is 30,000. My rate is 0.09. Number of times I'm going to compound in a year is 12. And I raise that to the 12 times 15. So first thing I need to do is simplify on the left-hand side, and then I'm going to divide both sides by 1 plus 0.09 divided by 12 raised to the 180th power, and then solve for p. So if I simplify all this left-hand side out, I end up with 3.83804 p. Divide both sides by that quantity, so p is going to be $7,816.48. So if I started with $7,816.48, I invested at 9% interest compounded monthly for 15 years, I would have $30,000.